Alright, so you're probably finally ready. You've just been waiting to figure out what the discriminant actually is, and I've been kind of giving you a lot of background. And so what the discriminant is, it is a part of the quadratic formula. So it's really not that complicated, and there's no reason for you to be freaking out, especially because you've seen the quadratic formula. You've seen it in previous years. You've been working with it for over a week now. It should be fairly familiar, and the discriminant is the part of the quadratic formula which is under the radical. So the quadratic formula, of course, as we've learned, is negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is the part under the radical, the b squared minus 4ac. So that's our discriminant, b squared minus 4ac. And you can see that this makes sense that, well, okay, so what the discriminant then is used for, you can just like see that and be like, big deal, what is it used for? Like, if I don't know how to use that, what's the point of just saying, oh, this part of the quadratic formula is the discriminant, so what? So the so what, I guess, then, is that this helps you determine whether a quadratic formula or equation has real solutions or not. So, so that makes sense because it's under the radical. So if this is negative, comma, then if the discriminant is negative, then it has imaginary solutions, right? On the other hand, if it's positive, comma, then it has real solutions. So remember when we were graphing a little while ago and we had our beautiful graphs of your x and y axis. Here's the y, here's the x. The solutions to quadratic equations are where they cross the x-axis. So you could have an equation like this and your solutions will be here and here. Or you could have one that goes like this and you have a solution here and here. Or you could even have one that only touches in one place and have only one solution there. But as we were seeing earlier, what if you have an equation like this, and the bottom of it's right here, and it doesn't go down any further than this. There's a horizontal asymptote here. Horizontal asymptote. It doesn't go any further than that. Like, it doesn't cross the x-axis anywhere. So it doesn't have any real solutions. It has solutions, but it doesn't have real ones. And of course, like, it doesn't have to be just an upward-facing parabola. You could have a downward-facing one too. And again, here you would have your horizontal asymptote, and it would never cross the x-axis or have any real solutions. So, so the discriminant then helps you determine whether an equation has real or fake, well, not fake solutions, but imaginary solutions. Because as we'll be able to see, you can actually solve, you can still solve these equations, you're just going to end up with an imaginary number in there. So, let's work through an example real briefly. Let's say that A in this example is going to be equal to 2. Let's say B is equal to 6. And let's make C equal 8. So in this example, B squared is 36. And then we'll have minus 4 times a, which is 2, times c, which is 8. So that's 36 minus 64. And that, of course, is, you just do it real quick, 64 minus 36. Let's cross that, I'll make it a 5. That's a 14. 14 minus 6 is 8. 8 minus 5 is 2. So then switch it around, it becomes negative, and we get negative 28. So if we were interested in finding the solutions to this particular equation, which I can just write it out real quick, 2x squared plus 6x plus 8 is equal to 0. That would be our original equation that we'd be solving for. So let me just set that apart up there. So if we want to solve for it, then we have this 28 under the radical. So now we have negative b, which is negative 6, plus or minus the square root of negative 28 divided by 2 times a, which is 2. So then we get negative 6 plus or minus the square root of negative 28 divided by 4. So obviously then this doesn't have a real solution because this is negative right here, which makes it makes the solution equal to negative 6 plus or minus 2i. So we factor out of 4, and then square root of 7 because it's still under there, divided by 4. And we could simplify a little bit more, divide the 2's. We could get negative 6, or 3, negative 3 plus or minus I square root of 7 divided by 2. And that would be our answer for what the solutions are. However, when you graph it on the axis, this graph right here isn't going to have a real solution. And we can check that real quick. We can throw this graph into an online graphing calculator and we can see that real quick. So let's go ahead and do that. Alright, so I've got the online graphing calculator pulled up here. We can just type in our equation. So 2 is a, so then it'll be 2x squared. We're going to, and then b is 6, so 6x, and then plus 8. And we can just put that in here, and we can see, oh my, this equation doesn't ever cross the x-axis. So it doesn't have any real solutions. So we found solutions, but the solutions are imaginary because they have the number I in them. So that's how you find that, and that's what you can use the discriminant for. It's so you can use it to determine whether or not an equation has real solutions or not. So that's the discriminant, and we're going to be working through a couple of problems together now. So just take a second to sit back, let that sink in, and then we'll be able to move on from there.